Hello, can you hear me now?
Yes.
Thank you very much. All right, thank you for joining the session. I wonder if you guys have a chance to look at the assignment. This is just Q&A sessions. If you have questions, I'm happy to explain. Let me pull out the assignment so we can look through those.
Really fast. On Wednesday, I did the blood drive and then was not feeling well, so I missed class. Is there anything we need to know from Wednesday's class?
We talk about the design rules, which you can find the slides on Blackboard. Those you can apply and you design the final thing. They're not really you don't miss that much. You can catch up by just reading the slides.
Okay, thank you.
Should be share screen. All right, so this is the one that I actually spent some time last Friday to explain it. I just want to design a problem that tie everything together. This is a application type of problem. I asked you to design a pressure vessel with composites, carbon fiber composites. It's the two parts. First part is designing a pressure vessel that satisfies the same requirement with metals. That'll serve as a control. Later on, you can once you finish design a composite one, you can compare with this one in terms of weight, deformation, things like that. That's sort of control case. The second part is really the meat of the project. I want you to do use your code. You design the layup, check the failure threshold, apply safety factor safety, and then calculate the mass, calculate the elongation with pressure applied, compare that with the metal cases. It should have most of the, I guess, all the condition you need to do the design. And then this is the data I want you to design based on the graphite epoxy data here on the last column with all the stiffness, modulus, thermal expansion. I do want you to incorporate thermal expansion. So I give you the stress-free temperature, 350 Kelvin. You should have finished your thermal stress part in your CLT, and that part should be turned on when you do that calculation. So the pressure vessel is 0.8 meter diameter and 1.8 meter long. It's a pretty big one. Design pressure is 10 bar gauge. So you can use the symbol equation to figure out the load in actual direction and hoop direction. That should be your design load. So the wall of the pressure vessel is under biaxial tension. So with NX and then Y applied, that's how you use your code. You can ignore the pressure perpendicular to the wall, which is much smaller compared to the in plane tensile loading. That's the majority of the loading. You can take a few minutes to read through this. If you have questions, you can ask me. The same document is also in the Blackboard.
It says that it's due the day of our final. Do we have a final, or is this our final?
This is our final.
Okay, cool. So there's not a test.
This is a final. You have final started now.
Okay.
Well, the other thing I want to point out is there's no single correct solution. You need to. So your layup is your choice. You can speak of efficiency of different layout, but is as long as it can resist load. take the pressure without failure is working one. There could be some layups lighter and use less material. That's better one, but there's no absolutely right or wrong answer. It's an open design problem.
I have a question of do you have a recommendation for the report length? Do you have a
no, as
one
long
would
as you
be?
describe your design clearly. As long as you describe you want me to whatever you write up, you want me to understand what equation you used, input to those output and conclusion, things like that. There's no fixed require. I don't require you to give me like 20 page or 10 page, 5 page. But I need a succinct, brief summary of your work, which I can understand if I have, for example, some issue to understand your total mass of the design metal structure. Your report should allow me to backtrace your calculations, your stress, your thickness, volume, density, and mass, and things like that. And you should, whenever you design certain failure important equation, you need to point out. Let's say you use a maximum distortion energy criteria, which is fine. To do the part one, you need to write that important equation out, and with input and output from that equation.
Okay.
So the answer is there's no hard
similar
limit of the number of pages, but you need to have a fairly complete summary of your design so I can understand.
Okay. And as far as the equation reporting, should be pretty similar to how the midterm was. If we use it, kind of just at least call it out and say what we.
Yeah, you call it out. I designed it with a maximum shear stress theory, and this is my shear stress. This is material properties. This is my calculation, and this is results.
Okay.
The part A. Part two will be longer because you're gonna lay out some. You're gonna put out some layups, right? You're gonna, based on design rules or whatever your sorts are, you need to describe what kind of layup you're studying and then calculations.
Mhm.
And then you probably want to do summarize the calculation for either case. And then you probably wanted to summarize the whole design metal case, composite layup 1, composite layup 2 in a table, comparing them in terms of mass, volume, deformation, things like that.
Okay, thank you.
Yeah. I mean, you can theoretically just give me one random layup. You said, I'll go with this. You build up enough thickness, you get a good stress distribution, not without the structure not failure at the required a safety factor. It's fine. Other guys may do 2-3 layup and they optimize and they draw a conclusion. They will certainly get better score. I mean, you could if you do a little more thorough study and report, you'll get better score. And the other thing is you might need to modify your layup, your code to allow more than a few layup. This may take a few layers, probably more than 2, 3, 4, 5, 6, or maybe more. So which you need to consider. One of the very nice resources is this slide I uploaded on Blackboard, which we did one lecture on this. There's some design rules. What's a good practice? Keep the layout, keep the laminate symmetric, keep it balanced. All those things. There are about total of 16 or 15 we talk about, but not everyone apply to this. The fastener rule is not applicable to this, but others they do. You can try to exercise these rules towards this design project. All right. Let's see. The ends of the pressure vessel is not in the scope of the design. So when you do the design for the metal case or the composite case, you ignore the ends. The ends are more complicated. So you only design the cylindrical part of the pressure vessel. So you basically assume there's no ends, there's no end effect. Magically, there's some ends that holds the stuff in, but you're not designing it. Is that understood?
Yeah.
Yes. Basically just doing the hoop stress from pressure
Oh,
difference.
there's actual stress too, by the way. Not only hoop stress.
Yeah.
The cylindrical part also sees actual stress.
Okay.
All right. You just
Yeah.
you just not design the ends. But the cylindrical part see two components, hoop and actual, both are active. So it's a biaxial tension. Hoop stress is higher than actual. If you analyze the load, hoop stress about twice the actual. Those should be applied to your COT code. Should be reflected in your calculation. You can calculate the load pounds per inch based on the 10 bar gauge pressure using a symbol pressure vessel equation. You can figure out exactly what is the load per inch length in the hoop direction and the actual direction using this single number, 10 bar plus dimension, 0.8 meter diameter. That's just basic solids equation calculation. PR over T and PR over 2T. If you remember that equation. Okay, so it's biaxial loading.
I'm guessing once we start this and run into if we run into problems with questions, we can just email you.
Sure. Yeah, we can set up another session if there's common problems. Yeah, absolutely. Yeah, I can help answer your questions in the. I think there are about 2 weeks. The 2 weeks, 2.5 weeks for you to finish this. Yeah, maybe a week before this due, we can do another session like this.
Yeah, that'd be great.
Yeah.
Thanks.
Yeah, I would appreciate that. I really wanted to sit through and see if there were questions I hadn't thought of. So maybe there will be more then.
Yeah, I'm sure they'll come up, and then I'll be happy to answer those. I just want to give you a chance to exercise your imagination and all the stuff you learn in this course together. It should be a nice exercise. Okay, if no more questions, I can sign off, and then we can connect next week. Hopefully you can, after you put some time into this.
Sounds good. Thanks. Have a good
Thank you,
Thanksgiving.
sir.
You too. All right, I'll see you guys next week.
Yeah.
Bye-bye.
Bye-bye.